Our next presenter is Allie Hamon, and Allie attends SIU Carbondale. She's a physiology major with the hopes of becoming a physician as well. Allie spent her SCI internship in the laboratory of Buck Hales. Actually, the microphones are up there. The disco ball looking things. Yeah. Actually, knock on that door because Maggie's in there. She's like, you know, the person behind the curtain.
Thank you. Oh, shoot. Yes.
We'll continue. So unfortunately, Dr. Hales couldn't be here today, so he sent me a brief story to share with you about Allie. And Allie, I am just the messenger. Allie joined the lab, this quoting all of this, Allie joined the lab early in her freshman year at SIU after being referred by her honors chemistry professor. Allie patiently sat through the lab group meetings for most of that first semester as she became increasingly involved in the laboratory. She sailed through her introductory exercises and started working on a histology project revolving around ovarian cancer. By the end of her first year, Allie had established herself as a solid member of the lab, and we were discussing the next projects we needed to tackle as a group. We were looking at the anti-cancer actions of cannabinoid, CBD oil, and they use a chicken model for ovarian cancer. So they were looking at the anti-cancer effects in their chickens, but no one knows the fate of CBD once it's ingested by the chickens. The lab had determined that it was not going to the yolk sac, so the next logical place to look would be in the feces of the chicken. At which time Allie, who's now end of her freshman year, going to become a sophomore, said with great passion, "That's why we recruit freshmen." She survived her first year. Now was her turn to take on a new student, which really shows what a significant part of her whole experience being in the lab has meant to Allie. This was her lab now. I couldn't be happier with her progress, thrilled to have her as a summer intern, and really looking forward to her continued growth in the project. Buck Hales, PhD, Professor and Chair, Department of Physiology, Biochemistry, and Molecular Biology. So, Allie?
Alrighty, thank you, Dr. Torrey, for the introduction. So yes, I've been working in Dr. Hales' lab since my freshman year on campus at SIU Carbondale. But this summer has been amazing time to just hone my focus in, because I'm sure everybody else that's pre-med knows how the classes go. So being able to just focus my time on research, and I'm super excited to share my experience with you all. So I've been working on understanding collagen's role in fibrosis and ovarian cancer. So to start, I'll kind of tell you a little bit about the lab. I got to work with Dr. Buck Hales and his wife, Dr. Karen Hales, both who are great mentors. We study ovarian cancer. So ovarian cancer is actually the 8th most common cancer among women. It's usually discovered very late stage, leading to a poor prognosis. This is because symptoms don't start to show until the cancer is already really late stage. This cancer also has a very high recurrence rate in women who are also receiving treatment. And it just results naturally over time with ovulation. So you can kind of think about this as falling off your bike and scraping your knee. So every time a woman ovulates, the ovary has to act like it has a wound that it needs to heal, similar to the scrape on your knee. So it develops a scab over time. So it deposits a lot of collagen and a lot of fibrous material to heal this wound, just like you would on your knee. So over time, this continual wound healing can lead to a buildup of collagen and over time also a cause of cancer. So we study with the chicken model, so that might be kind of unique, but it's a spontaneous and accessible model. So every day, a chicken lays an egg a day. Every time they lay an egg, they're ovulating. So by the time they are the age of 3, they're about the same stage of a woman who is perimenopausal. This model is also super abundant in tissues, so when we harvest these tissues, we get a lot to work with at one time. Bigger than a mouse ovary, which would be like super tiny. So Dr. Hales approached this issue by dietary intervention for prevention. So he told me a story once about how he was in the grocery store and he had noticed some omega-3 fatty acid eggs on the shelf. And he was like, how do they get that fatty acid into that egg? He's like, oh, they feed it to the chicken. So he decided to use a similar model when he was going through this process of attacking the ovarian cancer. And he started feeding the chickens whole flaxseed. So whole flax has many antioxidant and anti-inflammatory effects. So he wanted to see how that would react with the cancer. So there actually was, well, I've actually said fibrosis a few times. So you might kind of be wondering, what the heck is fibrosis? Well, fibrosis is actually just a buildup of collagen in the tissue. So we noticed whenever we were harvesting these hens, that the hens that had ovarian cancer, their ovaries were really stiff compared to those that didn't. And this was due to just a buildup of fibrosis in the tissue. There's actually been a lot of recent study on fibrosis, including in many other pathology in liver and kidney. We're hoping that it might be a way to detect ovarian cancer in earlier stages. This image here is actually some of the work I did this summer, some staining. This is Trichrome staining. So I won't get too in-depth in this yet, but this is an example of a very fibrous tissue, ovarian cancer tissue, that would be super firm if you were to squeeze it. So when deciding what I wanted to do this summer, I was looking back on some prior research. So Dr. Hales found that feeding the hens flax over time did show a decrease in incidence and severity of ovarian cancer. So you can look at this graph, and by the time the hens are around 3 years old, you can tell that there's quite a bit of a decline in the late-stage cancer. And by the time they're 3.5, the difference between the two is incredibly stark. We also have found that fibrosis is linked with this finding as well, so that the hens that are fed flax compared to that of a control diet had much less collagen and much less fibrous nature to their tissue. So one of the graduate students in my lab did some research on this, as well as a prior SCI intern, Emma Johns. So they looked into this visually by using trichrome staining. So trichrome is a type of stain that you do on the tissues, and it makes the collagen a bright blue color. So you can see in these images that as the cancer progresses, the collagen seems to be more and more prevalent. You can also see that in the control diet, the collagen appears more linear compared to the flax diet, where it still appears a little wavy. And collagen naturally is pretty wavy. And then Purab, the graduate student, quantified this data, and he found here that the cancer was a much greater amount in the control diet compared to that of the flax diet. So I took these past research ideas and developed my own plan. So I wanted to look visually at the tissues and look at the collagen in these tissues, specifically the control cancer and the flax cancer, and look at the difference between the two. So with this past research in mind, I developed the hypothesis that collagen would be in greater amounts and more linear in the control cancer compared to the flax cancer. So to start this, I gathered my samples. So in the lab, we call them the FAMES 4, and that's what's listed here. So I had 6 different hens for each group. Some were normal, some were cancer, some were flax-fed, and some were control-fed. And these tissues were already put into paraffin. So they're into this little wax block, and this is how they're preserved. So we take that little wax block and we cut it into these teeny tiny 5 microns little slices and put it onto microscope slides that we can use to stain. So different staining techniques I used were H&E, or hematoxylin and eosin, to just look at the basic structure of those samples. I then used Mason's trichrome stain, and this was used to assess collagen specifically. So we'll see some pictures of my staining from this summer, and that collagen is bright blue. I then used Pica Sirius red, which is just to complement that trichrome, and it makes that collagen bright red. So here is some of my data from this summer, some of my staining. So again, this is what stains that collagen bright blue. You can kind of see that as the cancer progresses, the collagen is much more dense in nature. You also can kind of see the structure of the collagen. So in this control diet late stage, it appears much more linear compared to the flaxseed diet, where it still kind of has that wavy nature. And then here's some of my data from the Fever Serious Red. So these are the same samples, but this red stain stains the collagen red compared to blue. And then it showed that my results for my trichrome were the same as the Fever Serious Red stain. And again, we see that really is linear nature, and here it's more wavy. And all these images are at 400 times magnification. I also started with some immunohistochemistry, which is another form of studying the tissues. And this is kind of a unique method that uses antibodies. So I was using the collagen 1 gene to look to see if we could pick up a signal with that. And I was successful with some colorimetric, but I wasn't able to get the fluorescent to work yet, so hopefully I'll be able to troubleshoot that in the fall a little bit. But this method works by exposing your genes and then picking an antigen that's specific for that one. So that's what the primary antibody is. So I chose collagen, and that primary antibody goes and attaches to that collagen. You then pick a secondary antibody that has a specific color with it. So say the color is brown, or if you're doing fluorescent, you can do bright red. That secondary antibody will go attached to that primary antibody and therefore make your gene show up in a certain color. So here is some of my colorimetric. I use DAB, so the stain is a dark brown. We're still working on troubleshooting this a little bit, but I just had one stain set. So the brown here is the collagen in this tissue. This is an ovarian cancer tissue. Okay, and then I get the unique opportunity to continue my research all throughout the school year in the lab. So I hope to take what I've done so far and move forward with it by first using second harmonics. So that's what we can send our tissue off, and then it'll tell us the pattern of the tissue. Is it more linear? Is it more wavy? So are my findings consistent? And I also hope to quantify the data. So several techniques listed here to see the amounts of the collagen in the tissue and see how the numbers compare. And finally, I would just have a couple of thank yous, but I would like to thank Denham and Diamonds as well as the Simmons Cancer Institute for this amazing opportunity. Over the summer, I've been able to apply knowledge that I've been learning in the classroom and really put it to hands-on use in the lab, and that is the best way to learn, let me tell you. It's also helped me develop better problem-solving skills, which are overall going to make me a better student. I'd like to thank Dr. Buck Hales and Dr. Karen Hales for being great mentors, for being very patient with me, and for making me a better person as well as a better student. I'd like to thank my friends and my family. And lastly, I'd like to thank you all for listening.
A question for Allie?
What you got?
What's the assurance that results or the pathology of chickens relates to humans?
So it is a very similar model because the process of ovulation occurs in the same natural way. We're not inducing the cancer in the chicken at all. I'm not exactly sure how closely it relates, but I know that it works closely enough that when you use like human antibodies and such, they work for the chicken model as well. So I think it's just a similar process that's because that's what causes the cancer in the tissue. So I would say pretty closely.
One other quick question for Allie? All right, thank you, Allie.
Okay, thank
Appreciate
you.
it.